Hi 111. In this video we're going to talk about the second kind of transformations. In the last video we talked about horizontal and vertical shifts, and in this one we're going to talk about how we can actually change the shape of the graph, not just its location, right? Because the horizontal and vertical shifts simply move the graph up, down, left, or right. These new kind of transformations are going to actually slightly change the graph's shape. And so these new kinds of transformations are called stretches or compressions, okay? And let's again motivate what we're doing in this video with an example. So let's start out by graphing these three equations right here. So let's graph x squared, let's graph 3x squared, and we'll graph 1/3 x squared. And again, remember, I want to say that 1/3 is in front of the x squared, so I'm going to put it in parentheses here to show that it is 1/3 times x squared. Okay, so let's go ahead and produce a graph. So again, remember, it does it in order. There's x squared, there's 3x squared, and there is 1/3 x squared. Okay, so let's just do a little bit of tracing here so we can see where we're at, and we can again move between the three graphs, remember, by using your up or down buttons here. So y1 we're currently on, and then you could go down to y2 and y3. Okay, so notice that y1, that x squared, is sort of the one that's in the middle between the two, right? If I sort of arrow up and down, y3 is the lower one, y1 is the middle one, and y2 is, oh, I'm all the way off the graph already. That y2 one's pretty steep, isn't it? y2 is that inner parabola right there, okay? Notice that I haven't shifted the graph around by using vertical or horizontal transformations, right? These graphs are not just vertical shifts of each other, right? There's actually something slightly different happening here. Let's zoom in a little bit. Here, let's zoom in, enter, at the origin, hit enter again. There's x squared, there is 3x squared, and there is 1/3 x squared, okay? So we can already see sort of that the shape has been modified here. The 3x squared is sort of like pulled up. It's kind of like a stretched or moved up, pulled up in that way, right? And the 1/3 x squared is sort of flattened down here, right? It's sort of flattened out like that. Well, we might get a little bit of intuition about what's happening here if we go to table. So see this table button, this table command right up here above the graph key. If I hit second graph or second table, right? This takes me to a table presentation of ordered pairs of numbers that satisfy the equations, right? So for our labeling system here, remember that if I go back to y equals here, y1 was labeled as x squared, so this is like y1, right? y2 is 3x squared, so that's y2, and y3 is this 1/3 x squared, right? Okay, so that's sort of how we have them labeled. Let's go back to table. So second table. Okay, so now what we can do is we can see pairs, right, ordered pairs that satisfy the equation. Remember, this is just like one of our ways to represent a relation or a function, right, with a table of values. So these are ordered pairs. When x is 0 in y1, we get y is 0, right? And so y1, remember, is this x squared equation. And so if we start looking to compare what y1, what this function x squared is doing, with what y2 is doing, and y2, remember, is 3x squared, we can see a difference, right? So notice when x is 0, we get what? 0 or 0, right? They both y1 and y2 do the same thing there. Okay, and that makes sense because they both pass through the origin, so that's okay. But what happens when x is 1? In the x squared function, y equals x squared, y1 here, it's just 1, and in y2 it's 3. Okay, let's keep going. When x is 2, let's see, y1 is 4, y2 is 12. And if we keep going down here, x is 3, and then y1 is 9, and y2 is 27. So notice that the major difference here between y1 and y2 is a factor of 3, right? The y2 graph here, the y2 points here, the y coordinate here, has been tripled. Yeah? And that's going to be true for all of these y values here. From going from here to here, we've actually tripled the y values. Okay, and that's, you can sort of see why, right? I mean, think about the order of operations here. When you plug in an x here, in this first one, it just squares it and gives you a number. But in this one, it takes the x, squares it, and then multiplies it by 3, right? So you're tripling all of those outputs there. Okay, and graphically, when you look at the graph there, remember that y1 is this middle parabola here, right? And y2 is the 3x squared, this one here in the inside. Okay, you can think about what's happening here. When I say x is 1, right here, yes, on the x squared graph, it gives me an output of 1, right? But on the 3x squared graph on y2, it gives me an output of 3, right? Which is way up here, right? Yeah, it's stretched and pulled up that graph and pulled up the y values like that, right? Okay, so that right there is an example of a stretch, right? We have pulled up what the graph is doing. We've stretched it up and multiplied all of the y values by some kind of a number, right? We've multiplied it by this 3 in this case. Okay. Okay, well let's see what's happening with this 1/3 graph here. Remember, that's this lower one right here, right? That's this sort of flattened out one right there. Let's see if we can get that on our table here. Let's see if I go over. Aha, there is y3. Yes. Okay, well, you know what? This y2 is sort of getting in the way here, so let's see if we can turn it off. So, I'd like to compare y1 and y3, right? So let's go to y equals. Here's a trick. If you go arrow over and put your cursor on top of the equal sign for the definition for an equation for a graph, if it's hovering on there and you hit enter, it's no longer highlighted. See that? See how it's no longer highlighted there? Right? What that means is you just turned y2 off. If you hit graph now, it's only going to show you x squared and 1/3 x squared. It doesn't show you y2 anymore. You just turned y2 off. So we currently have, if you hit trace, we have y1 and we have y3, and that's it. So now when we go to table, we can see just y1 and y3. Okay, so you can always turn graphs on or you can turn them off, right? Okay, so let's compare now. Let's see what happened. So our old y outputs here were for y1 for the x squared graph, and now these are our new ones for y3, okay? And notice what the difference is, right? The output values have all been what? Divided by 3, right? And that makes sense again because what happens here with the order of operations? You input a number, it squares it, and you multiply by 1/3, which is the same as dividing by 3, right? To go from here to here, then what have we done? So we have divided all y's by 3. Okay, good. And what that means graphically then, if we look at the graph, is that we have this graph here of x squared. If we go to 1 on that graph, if we input a 1 here, when we have x equals 1, the graph of x squared says the output is 1, but what would the graph of 1/3 x squared say it is if we hop down here? When x is 1, it's 1/3, right? So what we've done is we've compressed down this graph of x squared by multiplying it by a fraction right here, right? Okay, multiplying it by a number less than 1 is sort of compressing it down like that, right? Performing a division, if you will, right? Taking all y values and dividing them by 3. Again, that's the same as multiplying by this fraction right here. Okay, so let's summarize our findings here with an actual rule here. So let's say we have y equals f of x and it's a function. Then if we say make a new graph by multiplying that graph right there by some sort of a constant, see that thing right there? Yeah. If we multiply that graph by some kind of a constant like 3 or 1/3 or 1/15 or 5,000 or something, right? We multiply by some kind of positive number. We want to multiply by a positive number, okay? We'll think about what happens if a is negative next time. Okay, but for right now, let's just keep the a thing positive, the a number positive. If we multiply by some kind of a number, like in the previous example, we multiplied by 3 or 1/3 or something like that, then what we're actually performing is some kind of either a vertical stretch or a vertical compression. And the kind of change that we experience is dependent upon what kind of a it is, right? Notice in our example, when a was 3, right, when it was 3x squared, right, then we experienced a vertical stretch. All of our y values were tripled, right? The graph got stretched vertically up. It got pulled up, right? All those y values moved vertically away. They moved up, right? So we see a vertical stretch of the graph of y equals f of x if a is something bigger than 1. Okay. And alternatively, we will see what's called a vertical compression of the graph of f of x if a is some fractional number between 0 and 1, right? So if a is 1/3, like in our previous example, and then you say 1/3 times the expression, times the function, right? 1/3 x squared, like that, okay? Then that means that we are compressing the graph. All of the y values get smaller, right? So that means the graph gets pushed down like that. Okay, so that's this second kind of transformation for section 2.5. In our next video, we're going to talk about one last kind, and then we will summarize by doing lots of them all together.